Hi, so I'm going to go through part A of question 1 on the 2010 paper. So they say the values of k for which the line y equals kx intersects the parabola y is equal to x minus 1 squared are precisely which of these values? Okay, to find the intersections, we can put these equations equal to each other, so like this, and then to find the intersections, we just have to solve this for x. So if I expand the right-hand side, and then if I rearrange this all to get a quadratic equaling 0, we get to this. And so we want there to be intersections, and so we're going to need this equation to have real solutions. And so what are the conditions for this equation to have real solutions? Well, the discriminant is going to have to be greater than or equal to 0. And the discriminant is b squared minus 4ac. So if we look at this, then we see the discriminant of the quadratic is 2 plus k squared minus 4, and we need that to be greater than or equal to 0. Okay, so if we try and rearrange this to get a condition on k, well, first I'm going to take the 4 onto the other side of the inequality, and now I suppose we'll want to take square roots of both sides. But remember, we don't know that 2 plus k is positive, so we'll have to be careful when we take the square roots. So here is the graph of 2 plus k squared. I've also drawn the line y equals 4. And so we see that the quadratic is greater than or equal to the line y equals 4 when either k is less than or equal to this point of intersection, or k is greater than or equal to this point of intersection here. And so when I take the square root of this, either 2 plus k is going to be greater than or equal to the positive root of 4, which corresponds to this intersection here, or 2 plus k is going to be less than or equal to the negative root, which is this intersection here. And so if I rearrange these inequalities for k, we get, by taking 2 off both sides for this, we get k is greater than or equal to 0, and taking 2 off both sides for this gives us k is less than or equal to minus 4, and we see that corresponds to answer C.